Hello, welcome to the presentation, and this is the presentation of the chemistry and special that relates with the chemical bonding. So, chemical bond form in between two or more atoms, and that is because of the electrons transfer, electrons sharing, electron donation, electron acceptance. So acceptance of that particular electron and donation from one atom to the another, that is also relevant with the bonding. So bonding itself is one of the uh, fundamental property of different atoms of elements. We have to see the different elements are arranged in a periodic manner, periodic arrangement in the periodic table. So different elements are based on their the electronic configuration. So electronic configuration, and that can decide that whether any of the element can form the different or the same type of the bond. A chemical bond is the bonding between the two or more of atom of different elements. Simple example, the water itself, hydrogen and oxygen. So in between hydrogen and oxygen, the bonding is there. But now the question is there, why two hydrogen atoms are attached to the one of the oxygen atom. Whereas in case of the sodium chloride, one of the sodium and one relates with the chlorine. So why that particular differences? Even we have to take the calcium chloride. So in case of the calcium chloride, one is the calcium and two are the chlorine. So why this such type of arrangement, and what type of bonds are formed in between these atoms of and forming the molecule. So one main question is there. One more thing is there, the physical state of different compounds. So we have to see the different physical states of chemicals, of compounds, of materials, the solid state. So the example itself may be the water, in which the solid state is the ice. So whether the liquid state of water, that is the water, the gaseous state, that is of the whatever that particular water vapors. So water vapors, water and ice. These are the three different physical state of the water. Now one more relationship, and sodium chloride. So NaCl, the physical state is solid. So why at the room temperature water is liquid, and as well as the sodium chloride is solid? So this differentiate is because of the chemical bonding. So why that particular arrangement is there? And further, if we have the nitrogen gas or oxygen gas, O2 and N2. So those are in position of the gaseous state. So what the fundamental theories are correlated with those particular bonding. So we have to see one of the arrangement of those elements in a systematic order, and that systematic order, the periodicity in that way, and periodic table is there. The periodic table is the specific arrangement of different elements in order of their atomic number. So I think all of you know about the atomic structure, and that atomic structure is also with my the lecture series, in which you can see that particular lecture in atomic structure. So atomic structure explains the three different subparticles. What are those different subparticles? One is the proton, another is the charge equivalent electron. Proton and electron both are charge equivalent, only difference of the magnitude. Magnitude of proton is the positive in context of the charge, whereas the charge on electron is the negative magnitude. However, the value of those for proton and electron both are the same. So here one question arises: why that particular situation is there? So let's we have to continue our the periodic table, and in which we have to see the arrangement and how these arrange atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is the atomic number arrangement. Atomic number are the number of protons, and because the positive charge itself is also equal to the negative charge particles, so therefore atomic number means the number of proton or the number of electron. So the situation in case of the atom, that is whole, is the neutral. So three different subparticles in an atoms are the protons, then electrons, and neutrons. So neutrons having the those are the chargeless and no charge on the neutron. So let's we have to continue for that particular continuation, and for that continuation we want the different types of chemical bonds appears. Chemical bond, whatever the concern with the chemical theory of bonding, and lots of work was done by Linus Pauling in 1938. He gave the chemical theory of bonding. However, he also got the another Nobel Prize. So Linus Pauling itself is the double uh, Nobel laureate. So chemical theory of bonding explains how the bonding is occurs. Here, the different chemical bonds. The first one, ionic bond. So ions are collectively because of the charge on the ions, so they form a compound. Those are the ionic compound, and the bond between the two different atoms uh, of a compound, and that is the ionic bond. So ionic bond, because of the electrostatic forces, the different ions, the positive ion and negative ion, they um, uh, attract with each other electrostatic force and formation of the ionic bond. So the such compounds called the ionic compounds. Whereas in case of the covalent bond, there the electrons are shared. So how one electron of one atom and then electron, so they are sharing of electrons there, and the covalent bonding. My lecture is also present in the lecture series, and all of you can see that covalent bonding of compounds. So how covalent bonds are formed? Because of the sharing of electrons. And ionic bonds are formed, and here the different ions, the cations and anions are there, and they form ionic bond. One more question is there, and that question arises: what is the basics behind the formation of cation and anion? When we have to back to the atomic structure, and in those particular the main atomic properties, and those relates with the atomic size, whatever that can be correlates with the atomic ionic, that is the size of the atom, and atomic radii and atomic size. So that is one of the property, and further one that is related with another properties, we have the ionization potential. So what is the ionization potential? And one more is the electron affinity. And the most one is the also the electronegativity. So ionization potential of atom, one thing electron affinity, the other thing electronegativity. So in case of the electronegativity, the shared electrons are attracted towards which have the more electronegativity. The examples hydrogen and chlorine. So in between hydrogen and chlorine, whatever the sharing of electron, whatever the electron transfer. So in those particular the in covalent bond, the electronegativity is relevant, and therefore then the partial polarity occurs on the different atoms which are present in that particular compound. So now we have to continue that particular ionic bond. This is the part of the chemical bonding. We have already discussed about the chemical bonding three different types. The first one, ionic bond. The compounds will be ionic compounds. Electrostatic forces, so cation and anion both are there in case of the ionic bond. Then the second one itself is the covalent bonding. So covalent bonding because of the sharing of electron. The third one, that is the most relevant, is the coordinate bonding. In case of the coordinate bonding, however, that have also the electron pair, role of electron pair. But what we have, the situation is there donor acceptor relationship is there. So if any of the atom donate electron pair, so that particular electron pair donate, and one is the accepted by others. So therefore, that particular third type is the coordinate bonding. So coordinate bonding, covalent bonding, and ionic bonding. So this is the chemical bond. Role of electron is much more relevant for all those type of bonding. Even the role of electron is also gives us the advanced technology, whatever the advanced technologies in different engineering, even the computer engineering, the different materials are used, the electronics, then the electrical role of electron is much more relevant with the different technologies. And that so here also the bonding is because of the electron. So I think all of you know about the electron atomic structure in which the nucleus is present, and that particular nucleus itself, and so we can get the information relevance for that. Uh, the nucleus and surrounding is the orbitals. Orbitals, whatever the quantum number can be relates, that the shell number, the subcell, and then we get the atomic number. So whatever we can say that different, uh, uh, whatever different electrons arrangement in atom. So we have to continue for that the other part, and that will we can say that arrangement of electron is very responsible for the chemical bonding. One more thing is there here, we can say the valence electron. So regarding the valence electron, uh, those can participate in the bonding. One more thing is there, outer shell electrons. So here the concept of octet is also included. So every atoms wants to complete its octet. So that's why that is also the reason why chemical bonds are formed. So in case of the covalent bonding, electrons are shared. So octet is complete. Here one more thing is there, and that we can give, and that is the how we can arrange those particular electrons in an atom. So therefore, the arrangement of that particular electrons arrangement, and arrange how they are arranged, and that can be explained, and basis of the arrangement of electrons say that how many electrons are there. And one more thing is there, whether the electrons are present in s atomic orbital or in the p atomic orbitals. And in case of the p atomic orbital, further px, py, and pz. So chemical bonding, ionic, covalent, and coordinate bonding. Atom structure we have already discussed: protons, neutrons, and the electrons. The valence electrons, whatever the outermost electrons are generally, but how many electrons of that particular atoms bond. Valence C, and that is required. So, for example, in case of the hydrogen, one valence electron is one. So, the valency of hydrogen is one. In case of the oxygen, the valence is two. In this particular case, two electrons are for the purpose of the sharing of electron. In case of the nitrogen, three, and tetravalent is the carbon. So those are the valence electrons. Now the properties we have discussed: electronegativity, electron affinity. What about the electron are affinated, and electronegativity in the shared electron, and one is the ionization potential. Ionization potential that is of whatever that particular how many electrons are removed, and the example itself is the sodium. So sodium itself is the in the group of alkali metal. So in case of the sodium, if one electron is given out, so therefore that particular the ionization energy is concerned and cation is formed. So whatever the electron affinity is also correlates with the anion formation. Here, the different properties of atoms are responsible: electron affinity, electron negativity. So, we have to continue another. What is the ionic bond? And ionic bond, we have to come whatever earlier we discussed, all of the arrangement of electrons in a molecule. Molecule are the of the compounds. To compound chemical compounds, then we have the smallest is the molecule, and molecules where the different atoms are bonded. So here we have to come towards the ions. Ions, different ions. What are the ions? Cation, cation having the positive charge, anion having the negative charge. So in case of the cation, the charge is of the proton. The charge of the proton, and in that particular case, the charge over the electron. So if more are electrons, then the charge will be the negative. So negatively charged particles called the over those are the anions. Anions having one more thing is there, and that is related with the ionization potential and alkaline earth metal. In case of the alkaline earth metal, the charge is of the positive 2. So two charges are there, and plus 2, whatever that can be indicated. So ion, cations, the positive charge, po- positive charge ions, the anions having the negative charge ions. So both we can see, and those fundamentally obtained by that particular uh, fundamentally, this obtain the atomic properties. That depends on the ionization potential, the electron affinity. So because of that, we can say the cation and anions are formed when both combined with each other. Here also I can give one of the mole concept in which the Avogadro number. So the cations in Avogadro number, one mole of Avogadro number cations, and though combined with one mole of the anion. So that is whatever the 6.02 into 10 raised to power 23 particles, molecules in case of the compound. So particles here in case of the cations, the ions, and those are the one mole, the one Avogadro number, and that is the clear case in the Avogadro number, that the amount in taken in the weight, and that is taken in the gram. So that is related with the atomic weight. So here, atom forms atomic bond, and to become more stable, that is, atom become more stable by filling their valence electron, or at least meeting the octet rule, whatever, getting the 8 valence electrons. So now we have continued, and in this particular case, that is what we have, the ionic bonding. Ionic bonds are a type of chemical bond and which are based on the electrostatic forces between the two oppositely charged ions. So here, how a cation is formed. This when we have back to the periodic table, and from left to right, we have to see the alkali metals are arranged the left side, and then the p block elements are arranged at the right side. So the arrangement, one most that is the very specific arrangement of the elements. So here ionic bonds are the form because of the forces, because of the opposite particles forces that is in between the cation and anion. Now the question is why a particular element form the cation. This is specifically because of the electronic arrangement. So in case of the sodium, whatever sodium want for octet, whatever I have earlier discussed about the octet rule. So in case of the octet rule, any of the atom want to form in outer shell the 8 electrons. So ionic bonds are a type of chemical bond and which are based on the electrostatic forces between two oppositely charged ions, and it is basically the transfer of one electron from one atom to another. So that is the ionic bond. So here, in case of the sodium chloride is one of the ionic compound, and the physical state of sodium chloride is the solid. So why this solid compound is formed? That is because of the electrostatic forces between two ions. So cation and anion. In case of sodium chloride, the cation is sodium. So whatever the sodium itself losses transfer one electron, and when electron is transferred to another one, here the chlorine get the electron, and that become the chloride ion, that is the chlorine anion. So in case of the chlorine anion, that will complete the octet. So whatever that is the because of the positively charged ion. So basically the transfer of one or more electron in case of the calcium chloride. In however, in case of the aluminum chloride, 3 electrons are donated, so it's transferred from aluminum to 3 different chlorine. Sodium chloride, NaCl, the calcium chloride, CaCl2. Two chlorine are needed to complete the compound calcium chloride. In case of the aluminum chloride, that is one of the aluminum and 3 different chlorine atoms are used. So chlorine anion 3 and 1 is the aluminum cation. So that is the correlation, that is the equivalency of between the two different elements. But whatever the proportionate that indicate, so therefore aluminum chloride needs 3 chlorine anion. Why? That is because aluminum transfer 3 electrons easily and get the aluminium plus 3, and aluminium plus 3 is the octet is complete, and that is a like of inert gas configuration. So there are the chlorides NaCl, CaCl2 and AlCl3. One more thing is there, the nitrate NO3 minus. So therefore sodium nitrate will be NaN3. Similarly, here we can also get the something, the carbonate CO3 minus 2. So sodium carbonate Na2CO3. Then we have the calcium carbonate CaCO3. And when we have the aluminium carbonate. So basically, these the formation of the ionic bond, and this is the complete transfer of electron, and this one, the complete transfer of electron is because of the electron configuration, and the stability of any of the thing is our only because of the octet completion. So why octet? For the purpose of the octet completion, they gives easily electrons, and that is the property relevant with the ionization potential. So first ionization potential, second ionization potential, and third ionization potential, and those correlates with the sodium cation, sodium plus 1, calcium plus 2, aluminium plus 3. Now, the characteristics of these ionic compounds, they have the most characteristics are as follow. It is formed by the transfer of electron. This already I have discussed, lots of discussion we can get by the transfer of electron. It is formed between the metal and non-metal. This is also the very specific characteristic, because when we see the periodic table, so where are the non-metals arranged and where are the metals arranged? So easily we can find out in the periodic table. So here the left side is the metal generally. What are those? Alkali metal and as well as the alkaline earth metal. Then we have to see in between the known metals are the p block element, in which the carbon, in which the oxygen. So whatever we have, then further we have the halogens. So sodium halides itself, this NaCl and NaBr, those are formed, and they, because of the metal and non-metal, consist of the electrostatic forces between the cation, and this one is the most important relevant by which they become uh, versatile, then a different type of bonding, and that is the ionic bonding as compared with the covalent bonding, and that is because of the electrostatic forces. The ionic compounds are generally of the solid state, and they are soluble in the water. So let's we have the mechanism of the ionic bond according to the octet theory. When an atom takes part in a chemical bonding and tends to be the more stable, like the noble gas configuration, for that they need to fill with the 8 electrons, and its valence shell as a ionic bond made up by the transfer of electrons. The atom which took part in the bonding, neither it will loss electron or gain the electron. Either loss of electron completely transfer the electron, cation will be formed, or the gain of electron, those electron completely transferred from an atom, and those are gained by the another atom. Relevant example, potassium chloride. So KCl, potassium easily loses 1 electron because of the low ionization potential, and the chlorine get 1 electron, that is the affinity towards the electron. So let's metals have 2 or 3 electrons in valence shell. It is easy for them. But one more question is there. Easily they can transfer electron if suppose in case of the valence shell electrons are very little, whatever the one, two, three, and those electrons are lost. Electrons and non-metal accept very suitable for the electron gaining. So non-metals here the chloride get the electron that become the chloride ion, and potassium can easily give potassium cation. So when both combined with each other, then formation of the whatever that particular bonding after losing of electron, the metal transient. So this one totally relevant for that particular case. Now we have already discussed, but more relevant, the ions are formed how cation and anions are formed, and that particular is relevant with the formation of ions. So now we have to see that particular aspects ions are formed when atom gain or loss of electron. Ions are charged atom. Think charge is because of the electron having the negative charge. So charge value in the coulomb. So that is the for one charge, the 1.6 into 10 raised to power minus 19 coulomb. So the charge, positive charge, why positive charge? Ion because of the loss of electron, and negative charge ion because of the gain of electron. So positive ions are called the cations and formed when the atom loses electrons. Loss negative charges because of the positive ion. So here, uh, if electrons are lost, those are the negative charge particles, then the atom become the cation. So positive charge will be there. So if two electrons are lost, then dipositive will be there. So positive charge will be two, and that appears that get from the charge on the proton. So proton and electron both can be where we can say. So here uh, the atoms losses the electrons, and loss negative charge becomes the positive ion. After losing of a negative charge particles, then that become atom become the cation. Whereas in case of the negative ion, which are called the anion, anions are formed because of the gain of the electron. But here negative ions is called the anion, so that we have get the electron. So gain negative charge becomes the negative ion. Further, cations and anions are formed by, and these are anions are in generally the non-metal. So metals contain the positive ion charge particles, and non-metals having the negative charge particles. So non-metals, for example, oxygen. So oxygen get two electron and become the oxygen minus two. The chlorine get one electron, and that become the chlorine anion. So therefore, these particular specific arrangement is there, and that become the bonding is in between the two different and ionic bonds are formed between metals and non-metal. Various examples are available: the lithium chloride, the beryllium chloride, rubidium chloride, rubidium fluoride, calcium fluoride, CaF2, magnesium chloride, magnesium carbonate, whatever that may be also included, calcium carbonate, calcium bicarbonate. So metal with non-metal. Non-metals, whatever those are generally arranged in the P block elements. Those are, for example, oxygen is taken, so that is the example of the non-metal. If sulfur is taken, so that is example of the non. So specific here ionic bonds are formed. Ionic bonds have the properties, whatever that particular specific properties, specific behavior by which they are ionic compounds are water soluble. Now, ionic bonds are formed between oppositely charged atoms. Those are the ions, and ionic bonds are formed by the transfer of electron. One atom loses and gives away electrons, and one atom gains receive the electron. So now the question is there one the simple example or whatever the other example. Before that coming, we have to know about the Lewis structure dot form. So in case of the Lewis dot structures, different atoms are arranged, and each atom showing the different electrons, and specifically the valence electron, specifically outer shell electron. So therefore, we can make the bond, and here the bond will be of the ionic bond. So formation of ionic bond needs certain specific atoms, specific elements. because those specific elements can form only the cation, only the ions, and ions of the different types, cations and anion. So here the example is well known, alkali. Alkali metal that is present in a group or number 1 in modern periodic table arrangement, and whereas the halogens are in group number 17, 17, whatever this is as per the modern periodic table. So 17 group and first group. So 17 and first group both combined with each other. Here the stable, whatever the ions are formed, and those form. So alkali metal get loss of the electron easily. And why loss of electron? Because of the outermost electron. Only one electron is available. So that one electron, if transfer completely, then the n minus 1 shall become the outer shell, and outer shell in sodium cation. So therefore, in case of the sodium cation, the outer shell electrons are 8 in number. Similarly, in case of the chlorine, so chlorine from whatever in chlorine, the 7 electrons are there in chlorine atom. But if chlorine atom take 1 electron, then chlorine become the chloride ion. So here, similarly, here the halogens and alkali metals both can be combined each other. So here we can also take the example of the sodium fluoride. So in case of the sodium fluoride, we have to see the bonding, and here is the electron pair arrangement. So what happen in case of the fluorine? One electron is added, and the electronic configuration of uh, fluorine become whatever that particular the electronic configuration, that arrangement of the octet. So octet is completed in case of the fluorine as well as in case of the sodium. When one electron is lost, so that become also the whatever here 2 and 8, 10 electrons. So here 10 electrons are there. In case of the fluorine, 9 atomic number. So this will take again 1 electron. So this become the octet is completed, and here the total number of electrons are 10. So we can say 10 out of those first one, and the first cell having the 2 electron, and the second cell become. So similarly, in case of the sodium also, in the first cell, the 2, and the outer shell that become. So here also complete the octet. So whatever the positive charge and negative charge combined with each other and formation of the here, whatever the to name the binary ionic compounds. What is the name of sodium? Why we are putting the sodium chloride having the NaCl, and why we are giving the aluminium chloride for the AlCl3? So two elements, one metal and one non-metal, then cation is always written as the metal first. That is the sodium. And cation name stays the same. Cation name is also the same. That is the sodium. Anion is written second one. So first written the cation. Question is the potassium, and then the metal name is the potassium. That is the same name. So potassium cation is not in a combined form. This is potassium. So now the another aspect to give the naming of the binary ionic compound, and this is anion is written the second one. So known metals are the behavior will be that is of the later on. So chlorine that become the chloride changes the known metals when, and this ID is self is used in different sulfides, the chlorides, iodide, bromide. These are the used. So sodium iodide is NaI. So NaI sodium iodide, the simple formula NaI. Calcium iodide, the CaI2. Whatever the magnesium fluoride, MgF2. So two fluorine atoms, two fluorine anions are linked with the one of the sodium cation. So in case of the sodium fluoride, the question that the formation of the sodium cation and as well as the anion. So here when we are giving the name, so sodium fluoride will be there. So no prefixes are used for the ionic compound. Now there are the questions ionic bond formation. This depends on the arrangement of year. One more thing is there how because of the electrostatic forces they form a knitting work. So those are called the lattices. So where the arrangement of cation and anion and formation of a specific structure, that's why the bond these are the solid in nature. So lattice itself is formed in between the ionic. So the now the question is ionic bond formation, which depends on the arrangement of molecule or arrangement of atom or arrangement of the lattice. So the arrangement of the kernel. So correct answer, this is the lattice of the crystalline compound. One more thing is there. These ionic compounds are stable as well as the crystalline structure itself is there. So in case of the sodium chloride, we get the crystals of salt in a crystal of the namak. So namak or sodium chloride, the table salt. So that is the because of the crystalline, the lattice itself. So negatively are charged inside the substance, and it is dependent on each of the formation of the ionic bond as per the Kochel and Lewis ionic bond formation. So let's say we have the another question, and that is also related with the ionization energy. And here, whatever one of the question, and that endothermic reactions or the exothermic reaction. So what happen in case of the endothermic reaction and exothermic? Exothermic, then release of it endothermic that takes the energy. So ionization energy is always endothermic reaction. This is the false or the true. The correct answer is the B, and B is the answer. It includes the true. So how this can be explained? Ionization energy is the minimum amount of energy that is required to remove an electron from a neutral isolated gaseous atom. The symbolic representation is given by like that a gaseous state and this will lose the electron. This is the first ionization energy. If two electrons are lost, then that will be the second ionization energy of that particular element. It is always negative as it requires energy that endothermic in nature. Now, which of the following molecule formation does not include ionic bond? So here are the various examples of various compounds, various material. First one is the lithium chloride, LiCl. LiCl, the formation of the whatever the ions, lithium cation and chlorine anion. In case of the magnesium plus 2 and oxygen minus 2. Similarly, in case of the tin tetrachloride, the tin plus 4 and chlorine negative. So, in case of the water, that is what we have the molecule lithium chloride, magnesium oxide, and tin chloride are formed by the ion bond and they transfer electron from an electropositive atom and that donates to the electronegative atom. So that accepts when the water is the covalent bond. That is the sharing of electron in case of the water molecule. That is the concept, and that covalent bonds are formed because of the sharing of electrons. So in case of the water, bivalent is the oxygen and monovalent is the hydrogen. So one electron of one hydrogen atom and from one electron from the oxygen. They shared electron pair and that is the covalent compound. So others are the whatever the others are. So here one of the another question. and that can correlates what is the energy that is released upon the formation of an ionic compound. This is known as the correct answer, lattice energy. Explanation, whatever, when the ions are combined to form an ionic compound, and that is the crystalline solid, certain amount of energy is released, and this is called the lattice energy. That is the solubility. The property appears, volatility and hardness can be predicted. Hard material can be prediction. So solid as well as the hardness appears. Volatility and solubility, that is also important. Now we have to see the Lewis structure for the element sodium. We can draw the arrows to show the transfer of electron, and so now ionic bond easily form between when electron and when electron energy of this. This is the comparatively the correct answer is the D, that is the less. In this case, the rate of formation of ionic bond mainly depends on the tendency to become cation, anion from the original ground state. The tendency is maximum for metallic atom when whose ionization energy is less as compared to the other atom. One more question, formation of compounds through ionic bond, the ionization energy of the metal ion, and here depends on. So for the formation of ion, because ionization energy is responsible for formation of the ionic compound, and most one is the cation formation. So for the formation of ionic bond, the metal ion has to be overcome to energy for the removal of electron from its outer shell in order to become a cation, that is the ionization energy. So therefore, formation of compound from the ionic bond depends on the ionization. So thanks for that particular description of this presentation, and I hope these information will be more relevant for your study and more relevant for to get the innovate and uh, whatever is here to get the answers from the different questions related with different compounds. Why ionic compounds are soluble in water? Why ionic compounds not soluble in the non-polar solvents such as organic solvent? So organic solvent, whether the benzene, whether the acetone. So is it possible that ionic compounds are soluble in uh, benzene or other organic solvents, compound solvents? So let's more and more questions are here. Also, the lattice energy, how the lattice energy is responsible to become the hard compound and become the solid state. Not so. These are the questions, and many of the questions are there, and those relates with the ionic compounds. Ionic compounds are formed because of the ionic bond, and ionic bond are because of the basic property, atomic property, and those are the concern of the ionization potential. In case of the ionization potential, the energy, and that is then the formation of the cation, whereas the affinity that can correlate that easily takes the electron, and so though these atomic properties are even the atomic size is also relevant. For example, we can compare the sodium and calcium. So in case of the calcium, plus 2 charge will be there. In case of the sodium, plus 1 charge will be there. So they combined with the chlorine. So why sodium take 1 chlorine anion? In case of the calcium, they take the 2 chlorine anion. So that is the formation of calcium chloride, formation of sodium chloride. Even when we have to see the another halides here, sodium fluoride will be formed. So one more thing is the follow the octet rule. Here also we can explain any of the bonding with the help of Lewis dot structure. So Lewis dot structure also explains how electrons are transferred. In case of the sodium fluoride, we have already seen the electronic dot structures. So electronic dot structure also explains exit. What is the how electrons are transferred? So what we have this ionic compounds. So this one, and for the covalent bonding, you can see my other presentation, other lecture video in which the covalent compounds and covalent bonding is explained. So this is about this. I think, I suppose that you will get the more and more relevant information regarding the basics of the chemistry, regarding the chemical bond, regarding then we have the ionic. So that's all about this. So anyone having any of the relevant information he or she want, then he can uh, contact with my mobile number, with my email ID, and also share its review on the YouTube channel, and like that particular presentation. So all about that, and you can also see the Suresh Ganwar University website where different programs, different designed courses are there, and almost all of the courses are available at Suresh Ganwar University. And chemistry itself is the mother of all the technology, because every technology needs the. So this is one of the aspect regarding the use of the technology. So that's all about. Okay, all the best. So best wishes for, and thank you and giving your patience for the listening, and use these video lecture for the other